Welcome back to my channel. In this video we are going to discuss about a problem related to photoelectric effect. The problem is that in a photoelectric experiment, a stopping potential V0 is observed when a radiation of wavelength lambda is incident on a material. If another radiation of twice the wavelength 2 lambda is incident on the same material, what will be the stopping potential? The question is that in a photoelectric experiment, a stopping potential V0 is observed when a radiation of wavelength lambda is incident on a material. If another radiation of twice the wavelength 2 lambda is incident on the same material, what will be the stopping potential? So we have initially a light beam of wavelength, we have lambda. The corresponding stopping potential observed is V0. Now we increased or we used another radiation of wavelength 2 lambda. Then what will be the stopping potential? So initially V0 stopping potential is V0 when the wavelength is lambda. Then what will be the stopping potential when the wavelength is 2 lambda? We know that when a light radiation is incident on certain metals, electrons will be ejected from the surface. So the energy of the incident radiation will be used for ejecting the electron and providing kinetic energy to the ejected electron. Suppose E be the energy of the incident radiation, then that much energy is used for ejecting the electron and for providing kinetic energy for the ejected electron. So we can write it as E equal to kinetic energy of the ejected electron plus work function. The energy required to eject an electron is known as work function. So total energy is used for providing kinetic energy and work function. Initially, the wavelength of the radiation, the first radiation has the wavelength lambda. So it's hc by lambda equal to, for providing kinetic energy for the first case, so we write it as Ke1 plus work function. For the second case, hc by 2 lambda is used for providing the kinetic energy Ke2 plus W. The work function is, we have taken the work function same in both cases because the work function is the same for the same materials. We are using the we are using the same material, so the work function will be the same. So we can write the two equations as hc by lambda equal to kinetic energy. Kinetic energy is in terms of stopping potential, we can write it as E V0 plus work function W. This is equation 1 for the wavelength lambda. And for the second case, hc by 2 lambda, it is equal to the EVS, the unknown stopping potential EVS plus W, the work function 2. Now we can subtract equation 2 from equation 1. So subtracting equation 2 from equation 1, we obtain, what we will get next? Subtracting equation 2 from equation 1, we obtain hc by lambda minus hc by 2 lambda equal to E V0 minus E Vs plus W minus W. Work function will cancel. So here hc by 2 lambda equal to E V0 minus E Vs, or rearranging this equation, we obtain E Vs equal to E V0 minus hc by 2 lambda, or Vs equal to V0 minus hc by 2 E lambda. So this is the expression for the stopping potential. Vs equal to V0 minus hc by 2 E lambda. This is the expression for the new stopping potential. That is when the wavelength is twice that of the initial case. So thank you for watching the video.